Okay, well, hello. My name is Kaylyn Gibilterra. I'm from New York, and I work at Capital One. And as is probably fairly obvious, I'll be talking about NetHTTP APIs. Over the last few months, I've had this pretty fun experience where I've been able to build a team from the ground up, where I was the first engineer, and we're now about over 20 people. And besides me, nobody had real Go experience. A few people had played with it. But for the most part, everybody was learning Go for the first time on the job. And so what that meant was I created the first Go services, and then I had 20 people come in and be like, what's going on here? Let me ask a lot of questions. And a bunch came up around using just the NetHTTP library and effectively doing all of your router that a routing library would do for you, but we're doing it on our own. So that is what we are going to cover today. If you have been writing Go code, which is almost everyone here, you're probably familiar with these 15 lines of code. They're really nice, and I think a lot of people get super excited when they come to Go and they see these lines of code, because if you come from other languages, you might have to do a pretty elaborate amount of work to get your web server up, and that seeing something running this quickly can be really encouraging to new developers. That is until they try to extend their router. So what often happens is you write this first endpoint, and you're like, I am so smart, this is so fast, I'm like really productive, A+. And then you try to write your second endpoint where you're like, okay, now I need to like get one item from my like database. And when you try to do that, you get kind of confused. And it can be a little bit like, we just gave you the instructions to draw a couple circles, look, you have your server up, it's running, this is so fantastic. And now I need you to go production, like tomorrow. And this can kind of cause some intimidation. And I got to sort of see my coworkers like wonder if they should ask me a question, or like maybe it's supposed to be obvious. So that's what this talk is about, and we're gonna split it up into 3 basic parts. First, we're gonna dive into what those lines of code were, because it's really important to understand what's happening just in those 15 lines of code. It's gonna talk a lot about what's going on in Go, and then we can build upon our router from there. The final part would be kind of some extensions that I've used for various APIs and best practices that I like. If you're new to Go, or you've just written APIs and immediately pulled in a routing library, this should hopefully be a good talk. We're going to dive into some of the Go source code to show you what's happening on the internals. If you've been doing APIs a lot, and particularly NetHTTP APIs, this might not be the most informative for you. You might know how to do all of this, but I would encourage you to pay attention, because almost all of the points that I bring up through this talk are from questions that my coworkers have asked me, so they're likely something that you'll see from your peers too. So we're gonna get started. These again are the 15 lines, and these 2 lines at the bottom are kind of the most important. This is essentially where you're registering your endpoints and then you're starting your server. So what does it mean to register your endpoints? Right here we have this function called handleFunc. It seems to kind of make sense. You're gonna pass in this hello function, and voila, whatever you want to do in there, you can. But the really important thing to understand here is what we're actually defining to be a handler. So Go has an interface type for this handler, and interfaces in Go basically say whatever methods are inside, that's what you have to define for your type. To give a little example for that, I have a hello struct, and this could be any sort of type. It could be a string, it could be anything. But this hello struct has a method on it called serveHTTP, and it has to have this serveHTTP method on it in order to satisfy this interface. It can have other methods, you could have whatever else kind of you want in there, but as long as you have that serveHTTP, you're satisfying this handler, and we can use it. Now, this might seem a little straightforward, but what this looks like in practice, you'll see at the bottom here, before we had handleFunc and we were just passing in a function that could be called anything in there, now we have to pass in a value type that has this serveHTTP function on it. To give some examples, there's a few ways that you could implement this. So the top is what we just saw. It's not great. People tend to not want to have to define types for every single endpoint that they're creating, and then have a serveHTTP function in there. So what you can do is you can use the handle function, which then you pass in the hello function you have created with a wrapper of this handlerFunc. If you don't want to do that, though, Go has provided you with a much simpler shortcut on line 9 of this handleFunc that does the wrapper for you. to show this, because it can be a little confusing, and I've definitely gotten a bunch of questions about this, right here at the top, you can see from the Go source code, that's the handle func implementation. The only thing that the handle func implementation is doing is checking that you passed in a handler, and if you did, it does the exact same pattern that we showed before of handle with the wrapper to the handler func. Now, this handler func is sort of the important piece of information to get. Where this handler is effectively saying that you must implement a method that matches this serve HTTP call, and it will do that wrapping for you. So as long as your function has a signature that matches this, you can proceed, but every single handler must, in its core, implement serve HTTP. And this is effectively what your routing libraries are doing for you. Instead of you needing to be aware that everything has this serve HTTP function that satisfies the handler interface, Gorilla or Gin or Echo, they're going to handle that for you. Now, the next line that we have in our code is pretty simple. We're showing the base case, but this is your listen and serve, set up your server. The main parts here is that you're binding to a port. You could add in a host if you wanted. If you were doing this in production, you would want to set up your own server and provide different timeout options and connection pooling in there, but that's not totally the point of this talk. But what is important is that last parameter of nil. So when we're passing in the nil, it was discussed earlier, we're getting that default serve mux, and what we actually want to be doing is creating our own. And this is effectively the router. This is what, when you're pulling in the routing libraries, you're going to switch and use theirs for here. But what this shows you is kind of the full cycle of your web server. So you're starting a web server on port 8080. You're registering this mux router. When a new request comes into your web server, it's going to hit the mux, and it's going to look for any matching patterns before and see what they have before responding with the response. So I think it's kind of useful to see what HTTP can do for you, because I think this is where some of the questions come up and expansions come up. So what the new serve mux does by default is it effectively looks at all of your paths, it goes from the longest path to the shortest path, and it traverses through all of these subtrees or routes that you kind of have in here. It does a few things for you. So if you register hello goodbye, and it has the backslash at the end, if you type in hello goodbye without that trailing slash, it'll forward it over to you. If you want to specifically do one thing without the trailing slash, the first 2, 3, and 4 lines show it to you. With hello for one that passes through with the full subtree, hello without the trailing slash. And another useful thing that it does, if you want to register just that one trailing slash, that will catch all other requests. So if you want to just log that people are hitting at your server, you can do that with that endpoint. Now, there are some things that NetHTTP doesn't provide for you. So if we want to expand this, we're building maybe a REST API or sort of any real routing logic, you might want to do something like this. You might want to say, hey, I don't want to do just hello. I'm going to say hello in a bunch of different languages. So we have our salutations. And on line 3, we're showing I want to get all of the salutations you could possibly say to someone else. On line 4, I just want to get one. So I'm saying this, I have it in the brackets of language because that's my optimistic, it would be nice if that was there. And then on line 5, we want to use the same endpoint from before for salutations, but we want to be able to both post and get. If you were to run this code, you would get a panic at runtime, most importantly because you have 2 handlers referencing the same pattern. But also, it's just not really going to work. Go's going to look at that salutation/language, and it's going to expect your user or client to type those exact characters in. So you're not going to really get any information from your path in that sense. So this brings us to the next section of where we are going to actually build our router. So to do that, we create a simple struct. We're going to be storing everything in memory, not talking about how you set up your database now, but effectively you have your different languages and your different greetings, and we want to print them out and add to them. So the first request is we want to get all salutations that we have. This is the case that you could do normally without any additional routing. So what we're going to do here is we are going to marshal what we have in memory for the salutations. We do an error check, and I wanted to call out that NetHTTP does have a built-in error function that you can call. which is useful in many cases. It's also useful to see that this is a very common pattern when developing handlers and functions that support your handlers, is to have the function call, and then the very first parameter to that function is your response writer of W. And then at the very end, we write our response on line 7. A detail that I did want to call out, because I've seen quite a few errors actually on this side, is if you just use write, it's going to return a response code of 200 every single time, and it's going to try to detect what content type you're using. With JSON in particular, it's not going to be able to detect JSON. It's going to return plain text, which I've seen as a bug a couple of times. And more importantly, you have to set all header values that you want into your header map before you call the right header status code. I've actually done that by accident as a mistake. So what's important here is when you call the right header function, it passes in the header map that exists at that line of code. If you update any headers after that right header call, they're not going to be a part of your response, which can be very confusing. All right, so we have the get all salutations. Now we want to move on to the next endpoint, which is sort of specifying this language path parameter that we want. We obviously can't do it this way. So at this point, we have to kind of create our own sub-router. The NetHTTP library is not going to do this for us, so we're going to have to start putting in a little bit of work in order to get these path parameters out. So for me, how I label them is just the salutations router, aka this is the sub-router for this endpoint. If you have a lot of different endpoints, you'll make a few different routers for each one. A question that I've had come up sort of when I talk about this with newer developers is if you say, well, we're just going to start routing our request. They're often like, what do you mean? Like, how on earth would we do that? And it doesn't tend to sink in that we have all of the information we need inside the handler itself. Everything inside the request gives us enough information for us to do that routing and actually do some pretty complex and cool things inside of there. But I think it's very easy for newer developers to just sort of forget that that's a piece of data you have. So I wanted to call it out. And particularly for our routing, we're going to use the method in URL for that. The other important data type here is this URL structure. I'm calling out the path in here. The URL has a bunch of methods on it as well that are helpful when you're building your own router. But for the start, this is what we will be using. All right, so this is our very first simple router that we are creating. What this means is our mux at the top level has already parsed out that salutations is part of the endpoint. It wouldn't get here if it didn't exist. But we want to figure out if there's anything after that. So we're going to do this trim prefix, which is going to pull out salutations and return if our client has included anything for the rest of our path. If they have not, we know that they just asked for that subtree, which for us means they want to get all of the possible salutations. If they have included something after that path parameter, we're going to move on and do this get one request. An important note here that people have sometimes asked is we are creating this language variable, but we are not passing it into get1. I'll have some updates for that later on, but for a lot of things like middleware, it's very, very helpful if you keep the function signature the same, because your function signature still matches that serve HTTP interface that we want from earlier. So trying to keep that the same is useful. And on top of it, there's sort of the design principle of your router is just doing the routing and sending requests to what you could consider get all and get one to be the handlers. So those handlers should exist on their own and be able to get all pieces of data on their own without this routing logic having to have happened. So we can move on to this get one, which I forgot to change the name of. It says get salutation. So it's going to do on line 2 that same call again. It's going to do that trim prefix to get the language. We'll fix it later, but effectively that's what it's using to do that lookup and see does this language exist in our in-memory data store. If it does, we write that out. If it doesn't, we give the error message like before. So we have our first two set up. These are two relatively different endpoints, but now we want to add a third that is based on the method that we are passing into the request. So if you say get on this endpoint, we want to return to you everything. If you say post, we want you to be able to input new salutations. So this is how we start creating that. We effectively start switching on the method. So you can just do a really quick switch statement and include whatever pieces you want in there, like get or post, and do your routing in that manner. And of course, then you have the defaults to be set up for method not allowed if you would like. And this is nice. I think when people see this, they start to realize sort of the simplicity of like, right, I can control all of the requests that are coming in. And then we can do our create on that endpoint. I sort of showed a lot of code here. Not super important to like look through every piece of it right now, but I did want to highlight that this is a very common pattern for posting data, and it can be a little, you know, I see people's eyes glaze sometimes when they're looking at this stuff, but what's important is you're reading from the body, you're unmarshalling it into your data struct, your request structure, and then you do some validation. Those are kind of the 3 steps that I see all of the time, so I just wanted to point that out. But this is now our create. And now at this point, we have a pretty functional router. We have an endpoint. You could extend it with more versions, and it's pretty useful. If you have an API that's only like 1 or 2 endpoints, even if they're semi-complex like this, we haven't written a lot of code. But I wanted to include a few more extensions that I've commonly used, just to include you for thinking about as you go. And they are things like this. So if you were reading along earlier, you might have noticed that I wasn't really handling somebody who sent like salutations /1/2/3. This is one way that you can handle it. You can split based on the slashes and basically say, hey, I know I only expect you to be sending me 1 parameter. So if you're sending me anything other than 1 parameter, I'm going to say, that's not a page that we have supported. You could also do other sorts of things. You could have more complex parameters, and then you sort of can start nesting your routers if you would like to. I wanted to show parsing a query. It's so simple, I'm not entirely sure how much to talk about it. But I think people got kind of, I had one coworker who was like, wait, this is like the exact same amount of code, like lines of code as like our routing library. And I was like, yeah, actually, like some of it's pretty one-to-one. What happens here is you have the URL struct, which includes a query function that returns a map of all of the query parameters that have been passed in. And so you can search based on that. Now, I did want to kind of spend a minute on middleware. This is something that I think, especially if you're new to Go, or just more junior in general, can be a bit confusing because we are doing sort of a multitude of things here. And it's also heavily based on understanding what a handler is and understanding how you can transform any function into the handler type. So we are going to look at, we're going to create this log request middleware. Well, I guess we can look at log request first. So the first thing that we're doing right there is we are passing in what's called like next HTTP handler. And that's saying, hey, I need you to give me something that I explicitly know is of the handler type. And I'm going to return back to you something that is the handler type, and we can go through any requests that way. I've created this function in here because this function is going to satisfy the handler interface, so it has the same function signature as serve HTTP. Inside here, I wanted to call out on log 12, we're just logging the request. That's useful. But you can actually do whatever you want with the request in there. You could do a check that says like, hey, if the method is post, just like drop it. Don't go to serve HTTP, just like cancel that request entirely. I'm not sure why you might want to do that, but you could do a lot of checks on the request before calling that serve HTTP. And once you've created this function, you can now use it to wrap any requests for your entire API. So what we see on line 5 is this log request that is wrapping our salutations router. But it isn't just wrapping the salutations router because that's just a function. That doesn't say that it's explicitly matching this HTTP handler's interface. So we do have to call the handler func, which effectively transforms that generic function into one that matches the interface and pass that through. The final thing that I wanted to bring up, if you did notice how we were kind of grabbing language everywhere, that can get a little irritating if you have a lot of endpoints that are referencing the same sort of like account ID or user number or whatever. So the way that I go about that is to set your path variables inside the context. And there's a few things to kind of point out here. So what the context is every request has its own context. On the line 10, we are pulling out that context that currently exists in the request and adding in our own key and value. So for us, we're using language key, and then we're passing in whatever the user returned for that language. And then we set it back into that request. So any downstream request that is like handler that like looks at this request will be able to pull this information out of the context and use it, which is really nice. One thing to note, though, is it's best practice to not use like your key value as just a generic string. You don't just want to say like language key in quotes, because if you're using a distributed system and you have a lot of services that are passing through these requests, you could have multiple services using the same key, that same string. So by declaring our own struct, our own type for this, we're ensuring that the scope for this value in our context will be limited to our package. So it's something that can be useful later on. So these are all of my tips for building APIs. I wanted to show at the very end, though, this is all of our router. And effectively, it's only 30 lines of code. You can build a fair amount of extensions into it, but it doesn't have to be super complex. And I think this is really useful to see whether or not you want to build APIs with NetHTTP, because this can really help you kind of evaluate what you're doing and then what the libraries you're using need to be doing. So if you're mostly doing these switches on methods and on parameters, you can kind of look at your libraries and see if they apply for you or not. You probably don't need something terribly heavy-handed if this is sort of the work that you're doing. And if anything, I think this helps. You can kind of look through the libraries and read their code too and understand what's going on there. So I hope this was helpful. And if you have any questions, there's a lot more we could talk about with APIs beyond just routing. I'd love to talk to you after this talk. Thank you.